Okay, guys. I'll not spend much time. For 20 minutes, I'll introduce one concept. I'm planting those seeds. Then you'll be applying that one of these days. But let me uh, plant that the idea, the concept, guys. Everyone. Naina, Razu, Lahari, Hitesh, Mani. Welcome. Arun is also here to guide you. The concept is data ingestion. Please note, Databricks is a cloud data analytics platform. It sits on AWS. It can sit on ADLS. It can sit on Google Cloud. But Google Cloud market is very small. Most of the time, you either go for AWS Cloud or Azure Cloud. Azure Cloud. Okay, welcome. Subhashini is also here. Welcome, Subhashini. So I want to repeat this statement, everyone. Any company, first they decide their cloud strategy. Correct, Anush? First, the company, hey, we are going for AWS. We are going for Azure. First, they decide cloud strategy. It means they're already there. The decision is done. Now they decide, oh, analytics, we want to build our own on Azure or use some analytics engine of Microsoft. If they are in Azure, they have to take a decision whether to use AWS data analytics engine or more efficient in the market, use Databricks. It's just like any decision. Any decision. Anush, Subhashini, when we buy home, we'll see whether to buy in Frisco or Prosper, right? Go to Prosper, whether to buy from Tall Brothers or these brothers. Budgets, all is like any decision making, right, Anush? There is always a trade-offs. There is always a trade-off. Okay, so company will decide. Okay, hold on. Your company will be either Databricks on AWS or Azure Databricks. Assume. Okay, assume. Okay. Now we are talking about data ingestion, Subhashini. Data ingestion. So please understand, Databricks won't go and grab data from on-premise. It's heavy duty. There are third-party tools who most of the time put the data in the cloud first. They put either in or S3 or Azure Data Lakehouse. They put on the disk. Changes put there. FTP tools put there. So most of the time is almost like the food is there in the kitchen. The food is there in the kitchen. In the sense, the data is there to be processed. Already there in the disk. But there are sometimes where you which is Spark, Databricks, have to go to Oracle and get it. There are sometimes, maybe 10% of cases. But most of the projects, Anush, you'll have a handshake. Oh, Oracle system. Oh, you want to full load? Send me data every night or every hourly. There will be a protocol between the source system team and your team. If they want near real time, they will send it to Kafka. It means the data is available in Kafka. So most of your projects, the source is the cloud files. Let me use that word, cloud files. How about that? Cloud files. Cloud files, the source. But the real source may be Oracle system, MySQL, etc., etc. So let me share. There are few companies who are specialized in these areas. You will be hearing in your company, they also will be there. Something like Fivetran. Take this. See, Fivetran. Can you able to see everyone? Subhashini, you there? Can you see this? Moving data, powering innovation, FITRAN. See, they have all the connections, 40 connections, Oracle connections, Postgres connections. A lot of companies use this, trusted by the data. See the logos, Facebook users, that use, there's a lot of companies. So what these companies do is they have connectors to 40, 50 systems, SAP connections, Oracle connections, MySQL connections. They track what data changed and bringing it to the cloud files, bringing it to the cloud files so that Databricks can handle. It means they do one step like that. IBM stream sets, streaming data pipelines that enhance real-time decision. They do real time, they near real time, they also do the batch. When you say real time, sending the data to either Kafka or something. There are some open source tools like Debezium. See here, stream changes from your database. Debezium is an open source distributed platform that for change data capture. Change data capture. Start it, point it to your database, and your apps start responding to all the inserts, updates, and deletes. Right? In any Oracle, either you insert the data, you update the data, you delete the data. That's how the data is happening. So when the data is sent to cloud before Databricks process, they, it's a common sense. People, 2024, which month? October month. Sometimes they use weeks also, week 1, week 2, something like that. Generally, month and day. What date? This data. Is it, we need hourly data, then hourly. You need minute you can capture. You need second you can catch. You can microseconds. But generally, the very fact it is a minute, second, microsecond, they don't have to store on the disk. They can store in the some tools like Kafka. Why, Anush? Because if why you capture minute, it means you are capturing minute means you're running your jobs every minute, right? So even the job to start it takes sometimes a minute. Stop itself takes some time. So generally, you may have hourly jobs or daily jobs or not monthly, but generally a daily jobs if they are batch, hourly jobs, or every 4 hour job, something like that. But not a job that is running every minute. That won't be a batch job. Anush, is that fair statement?
Yeah.
Subhashini, is that fair?
Yeah,
The
Sridhar.
job. Correct. Correct. So that's why I put in the red. Right. So usually they store the data like that. So when you are running a batch job, Hitesh, Razu, Manadip, Naina, please understand, when you are running your Spark jobs, when you are reading it, you will have to go to that each hour as a variable, 22nd hour, 23rd hour, 24th hour. So you'll be accessing this folder, but that folder is changing, right? Every day, every hour, it will be changing, right? Eh, eh, Now, this is 22nd hour, you are processing this, right? Next hour, new folder will happen for that hour. So your job is looking to that folder, a very varying folder. Okay. That is the batch. Then what happens? So if file comes late, correct? Suppose I processed this an hour, 23rd hour. Anush, I completed. But one file came after I finished processing. Don't you think we need to somehow reconcile that?
Yeah.
Anush?
Yeah.
That's a common sense. This is common sense. So that type of issues are there if you are doing the folder by folder. That's why Databricks have come with a concept called autoloader. What autoloader does is, instead of you or your company designing your own mechanism, how to handle the late files, etc., autoloader does automatically. That's why that is the word autoloader. What? Let me see this. Autoloader. See, autoloader before means if the autoloader is not there, so when the file comes, if it is stream, okay, you go through some Kafka related. But even the batch, you run a job. This is Spark. This is just a scheduler, airflow file sensor, scheduler. It means when a file comes, it needs to identify, oh, file has come, let me process it. Or every hourly, you run it. There is a lot of heavy lifting is done here. So, or you should design a custom process. What are the files that are there? When you're running next time, oh, any new file came. All those logics have to be implemented. It's very difficult. Of course, earlier they've done it. But as we discussed, software improves every year or every 6 months, every month. There will be continuous improvements. So the autoloader, what does is it pipe data from cloud storage into Delta Lake as it arrives. Set and forget model eliminates complex setup. What autoloader does is, it's very simple. When you read through autoloader. What that autoloader is, it points to the folder. That's it, top level folder. And I say top level folder. That's it. Either year, this year. It means sales 2025, 24. That's it. Any files that are coming in this folder, you just process. Oh, now we got 30 files, say hourly running. At that time, what are the files that came, it process. Then next hour when you are processing, it processes all new files only. So it means autoloader uses a mechanisms to track what files I have processed, what are the new files that came. That's all. It's a very simple concept, but very powerful concepts. So it goes and, okay, this is the folder, sales 2025. So here, even though it is month, day, hour, even if the last month file comes, it process. Yesterday file came, again, of course, it checks the duplicates also. For repetition, there are some configurations. So those options are there. You have that in your mind. I'm just planting it now so that when you, in some of your projects or mini projects you'll be doing. So I'll just show you the quick syntax and give you some blog. Harun will help you at right time. Look here. See, it reads like this. Subhashini, please this. Spark.read stream format cloud files. It means cloud files means either AWS S3 or ADLS, whatever the cloud you are in the company. Option. What format? Cloud files dot format. Are you accessing JSON files or Parquet files, etc.? And where is that folder? From where you are reading, what is the format? And saying the cloud files means you are using the autoloader. That's it. That's it. So your autoloader, the word autoloader itself will keep track of any new files coming so that no file is missed. No file is missed. So that you don't have to write any logic, or whether I process this file or not, whether I process this or not, etc. It's a simple concept. Anyone has any question on that?
So,
Anush?
Srini, when we're using autoloader,
Mhm,
now we are going to point to the cloud storage for whatever it is.
mhm,
So it might be your DB or it might be your file storage or whatever.
mhm,
So how is the security? Because most likely it'll be a production instance.
mhm.
So how the security part of it? How
That's
are
a good.
how is that handshake happening between autoloader and is it something which is installed on your subscription
Okay,
or
that's a beautiful question. Okay, so that's a very important question. Okay, so any file you are reading, either through autoloader or regular Spark, the security is locked in the sense, suppose your job is running. The job is authorized. The job is the one which get the handshake with the cloud. Okay, I'm running a job either in dev or QA or in production. Is this job has authorization to read from this ADLS? Means does it have first access to this subscription, the storage subscription? Then in that cloud storage, does that folder is this job has access to this folder? Those policies are nailed down, Anush. So autoloader is nothing but a small library. That's it. Built-in library. It's like a small software. So assume it is nothing but a Spark, but with some utility. That's it. So your Spark is reading Spark.read that cloud files. It says, oh, it gets the same handshake on the security. That autoloader, what it does is it creates its own a what you called a checkpoint and checks whether this I process this file or not. It is like audit mechanism. Question, Anush.
so yeah, got it, Srini. And so it is this utility is part of the subscription, correct? So for example,
Part
you
of
want
actually Databricks, uh, not the cloud subscription. It's a
not
part of
part of the
Databricks,
so
which
but
has authority, which
got
which piggybacks on the cloud access.
it. Okay.
Hmm? Make sense?
Yeah. But sometimes you have some restrictions, right? So, for example, because these will be sensitive data. I mean, you have production data basically. So even though this part, see, where I'm like trying to understand is when that handshake happens between autoloader and your DB, whatever it might be,
Mhm.
storage.
Mhm.
Uh, is it just a regular, like a connection string which they set up? And because it's very restricted, right? Your DB access from an outside environment to your DB
Mhm.
or your storage.
Mhm.
So how is that restriction getting removed? Because it's all private within the network or within the VNet, right?
Correct.
So how is that
So
established?
that's a good question. First, don't think autoloader is a separate entity first. No.
Yeah.
First question is, does your job has access to that folder?
Yeah.
So you get your access to that folder out of some handshake, right? A
Correct.
sales data.
Correct.
This job has this access. Okay. And even to help you to answer here, now all these things are controlled by the Unity catalog, actually. So Unity catalog decides this location one, location two, location three, all the access policies, first of all. Right? So access policies left side. Then these jobs are right side. This job can access to this access location. This job can access to this. So it's a job level, first thing.
Got
So once you have the job level, that job has a PySpark code. That's it. It's a
Okay, so
job that
within the job itself, you're installing. Okay,
within that
got
job, the autoloader is a nothing but a syntax, a
it.
library.
Got
Got it?
got it. Yep.
But very good question. Uh, Hitesh, Manideep, don't get confused. These are simple concepts. Try to wrap around. Okay, because this will help you when you go to the interviews or when you start uh, doing your work. Oh, you understand. Oh, okay. If I just write a PySpark code, I read, but if any late file comes, this PySpark code cannot track that. So autoloader is another tool, in the same job, another software library, built-in library by Databricks, not an open source one, by Databricks, because Databricks is a platform, so it's a more efficient. So they will try to give more tools for you. So autoloader, so it means you just use the read. When you read, you use the word cloud files utility, but it uses the security of that job security. It's a secure. It's secure. Mandeep, you came from with visa, right? The legal visa only, correct, masters?
Yes, really.
Exactly. That is security. And you cleared the security checkpoint here, customs. Okay, hey, you came to your student visa, go. So that handshake here. So so that's how. It's a good question. Awesome. Subhashini, did you get this point? Autoloader.
Yeah, Srini. Autoloader.
Okay. Yeah.
Yeah.
Have that in your mind, but still some time is there how to use that. All those things are in, and we'll show you. But first, I want to plant that how the ingestion happens. First, again to summary. See, Databricks doesn't do heavy lifting of getting all the data from somewhere. Most of its work starts from when the data lands onto the cloud, either S3 or ADLS. ADLS means Azure. Then it reads, inject into raw layer, bronze layer, refine, put in the silver layer, aggregate, put in the gold layer, make it available for users to report, make this data available for machine learning, make this data available for any deep learning, make sure these pipelines run securely using Unity Catalog. Make sure this data is stored in the Delta Lake in a ACID format where users can read properly, write properly, all these things. So that heavy lifting is done by Databricks. The first to data landing onto the cloud part, most of the third-party tools like StreamSets, Fivetran, Debezium, Oracle Golden Gate, which is specifically for Oracle. And SAP is trying to do some connect. Since they know their systems, they can track what changes happening in the SAP. Those things Databricks doesn't do it. Databricks expect the file to come to cloud. From there, it will take care. Or if this data comes to a Kafka, like a water tank, then it start reading from that water tank. That is Kafka system. That is semi-real time. So batch on the disk and near real time from the Kafka. Have that in your mind. Have that in the mind. Only two things we'll be doing. You're doing batch, you're doing ETL jobs. Batch ETL, streaming ETL. Everyone say, Subhashini, can you say batch ETL, streaming ETL? Can you please say it out?
Batch ETL and streaming ETL.
Hitesh, can you say that? Murali, Manideep, everyone? Say it loud.
Batch ETL, streaming ETL.
Exactly. Don't think you'll be doing everything in the world. No, guys. Your job is to run batch ETLs. Your job is to run streaming ETLs. That's it. That itself is a lot of work. But it's not one streaming job and one. Sometimes you'll be handling 100 batch jobs. 100 different batch jobs. Sometimes you'll be in 50 streaming jobs. So you'll be in development, you'll be testing, or you'll be supporting them. You'll be doing enhancement, changes, etc. Awesome. Even it's a simple. Even when you walk, you just learn when you Hitesh, when you're a kid, you learn how to do a one step, second step. Next is all. Your third step is nothing but repetition. Step, 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 step. Then you walk, you can climb hills or you can run, you go this side, that side. That is what you figure it out. But you learn batch ETLs with PySpark, streaming ETLs with PySpark. The concepts why I introduced yesterday also, these gold, silver, bronze, silver, gold is so that you understand how these designs are done. Oh, okay. We need to get the bronze data. We need to refine it into the silver layer. You need to you need to aggregate into gold layer so that this data can be reported properly. The refining is needed because you want to add new columns or changing formats, etc. You need to fine tune, dedupes, you need it. Then you may ask a question: hey, why can't we do that in the first place, which is branch? Why can't we do that? Yeah, the branch you won't do it because you need some truth. If you change that, start changing it, you lose the baseline. Otherwise, you have to go always to the source. So at least you got here, you loaded this. Anytime even the silver layer is not good, your gold layer is not good, you can recreate them using this baseline. That is the first concept, very, very important concept. Wherever you go, you'll be listening. The second concept is how this data is coming. Data is coming from the source systems, OLTP systems, Subhashini, where businesses run. This data is captured with third-party tools. They bring it to the cloud yearly, in year, monthly, hourly. This data will come. If you can able to do your batch ETLs on it, but they can't address all the problems of data ingestion. That's why cloud files or autoloader is a tool which keep track of what file is coming, what is all these things, what we processed. Etc. So your job is to write simple code. Hey, read from that for the top level folder. That's it. Repeat it. Run it hourly, run it daily, run it even every 4 hours. Whenever it run, hey, these are the files, grab it and load it. Next time when you're running, what are the new files came? Grab it and load it. Because when it starts, it looks and lock what files are coming. Even when it is running, new file comes, it doesn't process. So 5 files I'm going to process. 5. Now next time it's running, another 3 files came. It processes only those 3 files. So it keep tracks of what files it has come. So there are the options. If the same file comes, whether to process or not, your team will come to a conclusion. Okay, if we come to a new file, let us process. Then there are the options you can change. I'll stop there. These are the ideas I want to introduce to you. First of all, have that in your mind. You'll be applying this as you progress. Any questions, guys? Let's simplify. Let's not complicate it. Simple concepts. That's it. Manadeep, thumbs up if you're good. Hitesh, Lahari, good?
Yeah. Yeah, Shini.
Yeah. Awesome. Naina, hope you got
Yes.
these 2 concepts, simple concepts. Excellent, guys. Harun, go ahead. I think they got a good hang of batch. Probably, I believe you are going to introduce streaming for them. They get the hang of batch and streaming. That's a good start. Then we can go to internals. Then you can go to the storage. You there? Harun, you're on mute.
Yeah, yes. So
Okay.
yeah, we will wrap up the batch today and review the complete all the concepts that we have discussed, and then I will introduce streaming, and we will also add some assignments today. Once the class is done, I'm planning to give a data file for everybody to just go through and come up with a batch processing for that file and submit the notebooks by end of the next week.
This week you are also giving them some references, right? Mandeep
Yes.
has asked where I
Yes.
can see the syntax and all. Yeah.
Yes. Yeah. All of that I'm going to provide. So Mandeep, you can connect with me or Shiva. Both of us, we will provide whatever is required.
Yeah, sure.
Okay.
Yeah.
Usually, mostly by next week, you get the good hang of batch and streaming. If we finish other than these another two classes, then we take this concept, go next level of deepness. Okay, first you got the good hang of batch and streaming. Then what happens in the internal level? What happens in the storage level? What are the best practices? All this comes. But everything from the industry. This is how we do projects. So you'll be comfortable whenever you're doing projects. Go ahead, Harun. Thank
Yeah, thank you. Let me share my screen. Where we are here. One second. Okay. So everybody can see my screen, right?
Yes.
So yesterday we talked about this. So anybody has checked the data sets from Kaggle?
Yes, sir.
Okay. Yeah, Lahari. So you got the data sets?
Yeah.
Okay, nice. And have you tried writing this notebooks, processing data?
Not completely, but yeah.
Okay. So Raju?
I done the basic parts.
Okay. Naina?
Yeah.
So as I was talking, sorry, yeah, go ahead, Naina.
I didn't do this, but I took the datasets from the Kaggle.
Okay, nice. So what we'll do is end of the session today, I will publish these notebooks. So you can import the notebooks into your environment, Databricks environment. Let me show you how you do that. Okay. So once you go here, workspace, and then you will have your folder, whatever folders you created. Okay. Or you can go here and say, right click, create folder. Okay. So once you create folder, you can give a name and create a folder. So you can go to that folder. Okay. And say clone, or sorry, not clone, import. So there is an import. If you go import, click on URL, and then I will give you a URL for the notebook. I will put it in this document here. End of this, I will add the notebook. So this is already here, this notebook. Check this out. So this also I will add yesterday's and today's notebooks, both for the data sets. We talked about the movies data set and also what we are going to discuss today regarding the Amazon products data set. So you copy the URL, put here and say import. So you will get the notebook here. Okay. Then you can create your compute cluster and then attach it and run that. Got it? So if you have any questions doing that, reach out to me or Shiva.
Yeah, sure.
Okay.
Yeah.
So yeah. So once I want to run through this Mizan data set, okay, because we will be wrapping up the batch processing today, this class, and then I will introduce the streaming concept. And we will also review end of the class what we discussed in this ETL batch processing before moving on to the streaming data today. Okay. Now, so we have the Amazon files here. Okay, cluster, select the cluster. I created new one. So I have 140 files, okay, for the Amazon dataset, all of these datasets. So now we have created a new cluster. As we were talking about it, we go here, all of this data is gone. So we don't have the databases here, right? So we'll go back, create all the databases, bronze, silver, gold. So they would come there. Now this is the file path. So see here, I'm not giving any one single file. So I'm giving the folder, and the folder has all the files. So once I run this spark.read, okay, .csv, this is the file path. Header is true, info schema true. So it will go, it's going to read all the 140 files under that folder and then show the data. Okay. And then we have seen these are the columns. What are all the columns that it has read, and underscore C0 is the ID that it has generated because it does not have a ID in the files. Now we are going to create bronze table product sales and then save it to database as the Amazon product sales bronze, right? Okay, so we got the data here. These are all the columns. Now let's write it to the bronze layer. So we were talking about it, describe table. So anybody who has done SQL in any of the databases like Oracle or MySQL or SQL Server, right? Anybody who has worked in the SQL world, they know what is describe table. It basically gives you the metadata about the table that you have created. What are the columns? What are the data types? Whether it it is nullable or not. I mean, which means that null values are allowed in that column or not. So that kind of data. So same thing here. So when I run the describe table extended, so I get all the column names here and the data type as string. See, basically, why it is string is we have, so if you look at the data here, see this is all of strings, right? Appliances, URLs, and everything is string. Ratings is actually double, and then there are null values also, but somehow it has, by default, it has taken string. Okay, so you can convert that ratings to double, and number of ratings also you can convert to integer. But maybe because it has commas and other stuff, probably it is not converting into the integer. And discount price and actual price, if you see, there is a symbol here, rupee symbol and comma. So that's why that is also not getting converted. So basically what we see here, these are all the data cleansing you do or data file to do while you do the data processing to get into the silver layer before you get into the silver layer. Now, what additional information you see here, extended information is database is bronze, table name is this, when you have created by Spark, type is managed. This is what I was talking about. We will talk about different when you talk about Databricks Delta. So what are the different types of tables that you have? So managed, external, and views that we have. Location we have seen, this is where all your data is stored. Okay, so even though it is a table, underlying somewhere you have to store the data. So if you go here, bronze DB, Amazon product sales. So this is where all your data is stored. Provider is Delta. That's the format that you have given. Right. So those are the properties that you see. Okay. If you go here, so let's see, you have done this. This is done. So you can, so this right? So you can get it from spark.table or you can do a SQL. Both of that is same. Now this is called delta log, right? So when you create any table or write any data into it, so we looked at the path. So db.bronze Amazon product sales. This is the table name. So there will be a folder created with the name of the table. And under that, there is a delta log file. And then there are path files. So this is actual the data. So what is there in the delta log, we'll come to it. And then we'll talk about it when we talk about the Databricks Delta after the streaming. So once we cover the basics and foundation, we will go into the Databricks Delta and the Spark internals, those two topics. So for now, so each of this is a file. Okay. So this is the name of the file. So if you look at the name of the file, it is .parquet. So all delta tables, so whatever format you give delta, underlying the data is stored in the Parquet format, and the snappy is your what you call compression. So the files are compressed using snappy, and then it's a format called Parquet format that it is written. So all of the data. So when you do retrieve data using spark.read or select star from, it kind of goes first into the delta log where the metadata is written. It will make sure it will go through, read the delta log and see based on your query what files it has to read. Maybe you have written some where clause and it knows, say, where category is equal to something or appliances. So it knows all appliances are in these files by category. So it will only pick those files to give you the data. So all that processing happens before you get your data back. So we'll go through in detail how all of that processing transaction happens based on the delta log. Okay, the Databricks Delta. But you have to remember this. This is the path. And these are the files that are written based on your transactions. Whatever you append or overwrite or update tables, all the information is written in this path for that particular table. So now, any questions still here? Just give me 1 second. Okay, sorry guys. So any questions still here? Raju, Naina,
No, Arun. I mean, so far
Anush?
uh,
Yeah, go ahead. Sorry.
so far the data is at initial layer only, right? Bronze layer, not into the next layer.
Yes,
This
this is
are
only, yeah, we are still in the bronze. We just returned to the bronze. So if you
okay.
look at the table name,
Mhm.
so it says
Mhm.
bronze Amazon product sales. That's the table name
Oh,
that we have given,
oh,
right?
okay.
So
Right,
based
right.
on the table name, it will write here.
Okay.
Okay.
Thank you.
Now, what we are, okay, anybody else? Hitesh, Manideep, Murali? Guys, come on, speak up. Are you guys good till here?
No, yeah, I'm good. Yeah.
Yes, very good.
Okay, nice. Right. So now what we are doing from the bronze table, so we have written df bronze. So what is df bronze here? Df underscore bronze. Anybody? What is df underscore bronze?
Data frame.
Data frame. Okay. Read from here.
Table, yeah.
Bronze table name. So we have read spark dot table, bronze table name, df bronze. So basically we are writing and then reading back. Okay. We can also use this. So we have written the same thing. Okay. TF bronze data frame. So we have written the same thing and then we have read back. So this might be read. Okay. So we have read from DB or you can name it from DB, whatever. And then run this. So basically this and this are same. This is what we have written to database and then we are reading back from database. Okay. So we can use either of that. It doesn't make any difference. Now we read that data frame. Okay. So let's say we take it from DB dot select. We are selecting columns and then I am doing alias. So which is like I am renaming. Okay. So C0 as product ID. I'm giving the column name as product ID for underscore C0. Name as product name, main category, subcategory, image link, ratings as double. Okay. Link as a number of ratings and regex replace. So there is something called regex. Regex means regular expression. So basically it's a Unix concept where it's a function basically in any language where you can search for certain characters in within the string and do some operations, replacing or removing or splitting, whatever we can using the regular expression. So it will take that and search the string or whatever column and then do what we want to do. So regex replace, what we are doing is taking the discount price column, okay, and then apart from D, so this is called, there is a syntax. So don't worry about syntax. You don't need to learn this. You will get it online. So, but just understand what this is. So what we are doing here is taking any digit and comma, decimal, digit and decimal, okay, and then everything else we are removing because we are replacing with null string. So what it means is that if we go here in the data, if we look in the data, see what characters we have in this. We have a comma and then we have a rupee symbol, right? So except numbers and dot, which is a decimal, except for those two characters, numbers and decimal, everything else we are replacing with null, which means we are removing basically. Empty string we are replacing with. So which means that we are removing those other characters, that rupee symbol and comma. So then we are casting it as double from string to double, which is decimal. We are changing the data type from string to decimal, and then renaming the column as discount price. And same thing we are doing for actual price. Everybody clear? And entire thing that we have selected from here, all of this, we are storing in a data frame. So everything when you do select whatever transformations you do, it will always return a data frame. So we are storing in DF Silver. Yes, somebody has some question?
Harun, so we are, so for example, we are using multiple data frames here, correct? So instead of using or updating a single data frame, we are creating a memory footprint by having multiple, right? We have data frame read, then data frame, sorry, DF bronze DB, then DFC. I mean, okay, just think about DF bronze and DF bronze from DB. Right? So this thing, it's basically memory, correct?
Yes.
So how is like how is that impact going to be on the process? Like, should we be cognizant about how many data frames we create?
Yeah, that's a very good question. Okay. So it ties back to how Spark is processing. Okay. Spark actually uses something called lazy evaluation. Okay. There is a concept called lazy evaluation here when you do any data frame. So what it means is that whatever you write on a data frame, it will not immediately run. It will store all the transformations. And when there is an action, so I'll tell you what is a transformation and what is an action. That is when it will go. It will create a DAG graph. So that also we will cover the concept in the Spark internals, how Spark is processing. Directional acyclic graph. Okay. Which means it will create a graph of events, what it has to do. Okay. First, I have to read this file. Then I have to change this column names. Then I have to change this transformations. Then I have to run this query or filter. And then I have to create this data frame and all of that. So when finally you are executing and writing to database, that's when it will go back and execute all of that actions in a sequence, in transformations in sequence, and finally give you the data frame. Okay. So what happens in this process is, let's say you created 2 data frames and then you are using the second data frame. The first data frame, you are not using it. It will automatically get recycled or garbage collection. You're not using it in further in the program. As you know, the moment you cross that, it will see, okay, this data frame is not being. So for example, we have here data frame. So DF bronze. Okay. Now I have created another DF bronze from DB. Now, if there is no reference to DF bronze after this, right? So it will automatically get it recycled or garbage collected. So we will not have this thing in memory after this. But somewhere down the line here, if I am again calling the DF bronze, that is when it will still keep it in the memory. It has to, right? Because at this point, it cannot go back and then see, there are 2 things. It can go back and recalculate everything. So I'm calculating DF bronze. So again, it has to go to read the file, process it, apply transformations and give you DF bronze. Or you can cache it. So that also we will talk about. But basically, yes, you are right. There is a memory implication when you are creating multiple data frames. And basically, if you're using all of them, if you're not using, that's fine. It'll just get recycled. But if you are using it, yes, there will be multiple data frames. One, you can cache it so that it doesn't get recalculated, but still it lives in the memory. 2, it gets recycled if you're not going to use it. So it's best if you have a data frame, use that. But if you have transformations, you get a new data frame, you use that. The old one is still there, but you are not referring to it, it will get recycled.
Yeah. Okay.
Okay. But yes, yeah, you're right. So there will be memory implication if you keep on creating. I mean, you have to do transformations anyway. It's just that even if you don't put uh, the variable, it still will give you a new data frame anyways, because it is immutable. It is not updating the existing data frame. Okay, it will still give you new data frame. The old one is basically recycled if you are not using it. Okay. So, but all of this is a just the abstraction on the actual data that it is processing. Everybody clear on that? Okay. Yeah. Any other questions before we proceed? No. Okay. Good.
No.
Okay. So let me run this. This show and display. So you can see here basically dfsilver.show or display dfsilver, both is same. Both are same. It will show the same thing, but it's just different way of display. And that's all. Okay, so we have done this processing, and now you have, see, ratings is a decimal here because we converted to double. Okay, number of ratings we have not done. Discount price, actual price. See here, see there is a shift. So data is not correct here. The price has come into number of ratings, right? So something has gone wrong when you are processing this. Product, everything is shifted to right. Product ID, because there is no C0 column here. So the next column is read as product ID. Okay. Now, if we read DF bronze, and did the same transformations, oh, it's still product type. C0 is not, where is C0? Let's see. DF bronze, where is DF bronze? We'll go here and say DF bronze. Display. Okay. See here, the C0 is being written, is read as product name. So there is some shift in the files that happened. So you have to make sure how you are reading the actual files. Otherwise, you get the data skew like this. So you are getting the bad data into this in the transformations. So this is something what you have to always make sure when you write business rules or whatever validations, that you are getting proper columns. Okay. So basically, if you not getting here, product ID is not there, right? And C0 is being written as read as product name. So this is DF bronze. Let's go here and see. what we have written into the database. Okay. So C0 is actually the product name and everything has shifted. This is the main category. This is subcategory. Okay. So we have, this is not properly written to the database. Correct?
Does the file
Yes.
have it, Harun?
Sorry?
Does the file, I mean, we were trying to put it to the tables, right, on the file.
Yeah.
Just wondering if the file itself has all those columns.
Yeah. So what we did, this C0 is not written. Okay. So C0 instead of ID, it has written as the first column as the name. Okay. So that's why it has come into this name. So what we can do here before, when we've written this, because we are not doing any transformation on the bronze, right? So DF bronze, we are not doing any transformations. Okay. So we can showing here as C0, but when we write, this is not the actual column from the file. So it is just showing in the display for the data frame. So we have to convert this and then write only these columns. Okay. Let me see how we want to manage this. Most of the times this won't happen because there are already whatever columns you read, those are the columns you get into the data set. And specifically for to start with, just use one file. Don't use the folder because you have so many files. But for this, since you can do aggregations on the category and subcategory, so that's why we are using all the files. So what is, so here Amazon product sales. Why is it writing this as C0 instead of name? Okay, let's take this DF bronze here. And then I'll just remove this part. We don't need this. I don't want you to get confused. See, most of the times this will not happen in production or in the industry because you always get a specific, there's a contract which says the source will always send you these columns and this data. So only based on that, you will create your programs, your pipelines. Okay. If any of this data skew or something happens, you will write it, you will create a issue or bug or production ticket that the source files are not coming as per the expected structure. So your program will fail or you will stop based on the business rules you write. You go back and raise it to the source system. They will fix it and send it back. So then you take and reprocess that. So that's the process that happens in the actual projects, right, Anush?
Yeah. So can you check this file itself? Probably not sure the first file.
Yeah, files we can check. 1 second, let me see what we have in the files. Do we have? Where's the, okay, let me get from Amazon data set. Okay, so this is the file. So if you see here, there is no ID column here. It starts with name, right? Name, main category, subcategory. So that's how you are going to also process. Somewhere when it is reading, because it has multiple files to distinguish, just to show in the data frame, it creates underscore C0 as the ID, but which is not there in the actual file. Okay, so that's what it's showing. You can handle that. Okay. So instead of writing to the database, when it writes, it eliminates those IDs. So what we are doing is we are directly taking the bronze data frame that it has read. Okay. And done this, all the transformations here on that data frame that we have read. We're still not written to database anything, even the bronze yet. So here you can see it's product ID, name, everything is parsed correctly. Main category, subcategory, link, ratings. You can see here, number of ratings, discount price, and actual price. So what we will do for this data set, let's keep writing to database. I mean, you can do everything in memory, right? So bronze, silver, gold, everything final. You can do that. So let's say you can write it, but I'm just taking it for, we have not written the business rules. So I will just take this bronze data frame for all of this transactions. So all this is still good.
So, one question. So when it is creating this CEO column, right, by default, is it like a auto increment identity column which it uh, creates by default, or because we didn't specify it, right?
Yeah, so somehow it is only doing for this because we have given the folder name and multiple files within that, but normally it doesn't create that. But
Oh.
since it's doing it for multiple files, we have parsed it as a new column from the data frame. Okay, and okay, so now we have got all of this transformations done, right? Now, based on this, see, I'm using the same data frame name. So whenever I do a new data frame, the old one is removed because I'm using the same variable name. So the old one will be removed. df dot filter. Okay. So once you filter is not null, you will get only ratings where you will get the data frame only where the ratings is not null, right? So if you see here in the ratings column, there is some null here, right? Here, null. So what we are doing, we are removing all of this data where the ratings is null, okay? And we are also filtering the ratings less than 0. So we are only taking only the products where rating is greater than 3. So these are just some examples of transformation. Don't say that we have to do this for everything. If we want to do any analytics, null values will not have any value for us, right? So we cannot do actually anything. Those are not relevant to us. If there is null, it does not mean anything. We don't have that information or that data. So we are filtering out ratings, discount price, actual price, which are not null. And the lower ratings ones we don't need. So we are taking all of that out. Now, if you see here, it has 1,103,000 rows. So once I do this transformations, okay, and I can do a count on this and see how much data we will get. So this is when we are enriching it, we are filtering out the bad data where, nulls and everything from bronze layer. So we only have 294,000. Okay. So almost 70% of the data, 70 to 75% of the data we have eliminated. At least for our use case, we don't need it. It's still there in the bronze layer. I mean, all the data is valuable. We can always go and send that data back and say, hey, 70% of the data is still bad quality. We are not getting values. Can you just fix it? Try to see, get values for these and send it back for processing. If there is no values, yes, we need to filter it out as bad data, because if we use all of that, and then if we go and do any analytics on that, we will get skewed results, which is not true, right? So that's why this is all data preparation. So we are filtering out the bad data or data with bad quality, null data or lower ratings things we don't need. Okay. Then we can say df silver. Why do we need both? Okay, display. So here we have this data. All the ratings you see, you will not see anything less than 3 in this, and you will not see any null values in this. Okay. So finally, we can go and write this data to silver. We don't need again this count. We've already done. And show and display both are same, so we don't need that. Okay. So now I'm going to write this data to silver. fail to merge field ratings and ratings. Okay, so it's trying to merge what? Okay, from different files. So let's use the option for now where you can do so have we written anything already in the catalog? Okay, it's not written. What is this? Let's see what it's saying. Okay. Dot format override. Let's try this. Okay. Let me try this for this file has some merge schema option. How do you write merge schema? So it's just an option you can add when there is a change in any of the schema to take care of that. Oh, not merge schema evolution. Let's treat this. Or we will continue with this and then we will see. We'll fix it back. It still says cannot merge. So there is something, some issue with the ratings column. Okay. Some data issue probably because there are 140 files somewhere. Some data may not be correct. I will, let's check this. Okay. We'll circle back and see what, because we don't want to spend time troubleshooting the data issues here. We want to focus on the concepts. Okay. For now, we can still continue with this in the silver data frame. We already have this. We are not writing this, so we don't want to read this here. Now we can perform aggregations on the data set. Okay. If I just say this. So we have in the data frame, we have C category, right? So we have main category and subcategory. Let's say we want to do an aggregation by main category and see what is the count. Group by main category and subcategory. What is the count of each main category and subcategory? You can also do a discount price, average of discount price from main based on each category. So what is the average price for each category? And then we can write it, or we can just say display. Okay. So what I will do here let's run one of this. And then say display this data frame. So what we are doing here is we are doing aggregations. Okay. So we want to see how many each category products are there by category. So if you see here, women's clothing count, men's shoes. So these are all the categories. Okay, that we are showing here, 21 categories, main categories. Now, if I want to do a group by subcategories, so you have to first do a main category and then do a subcategory, right? Group by category and subcategory. So if I do this here and then say display, what is the subcategory count? You see here. Now, here we have seen kids fashion, 5,000 rows. So within the kids fashion, now we can see kids watches is 150, and there will be more rows here. Where is the kids fashion? Or we can take home and kitchen, right? So home and kitchen, pets is home and kitchen. Home and kitchen 11,000. So within that home and kitchen, we have garden at the outdoors 800, home furnishing 1250. So basically we are doing the next level of subcategory on this. Now for each of this, you also have discount price. What is the price that you have? So you can go and do the average of that pricing. So this is all now average discount price based on each category and subcategory. So if I want to know what is the discount price on home storage, right? So that we can do. So here I'm doing group by main category, subcategory. Then I'm taking average of discount price. And basically I'm just renaming those columns here. Okay. And let's say I want to go here and then say display average discount data frame. So in Python, I'm not sure if anybody has experience with Python. In Python, there is always indent is very important. Okay, that is how it will make sure how is each block of the code, the scope of the block is defined. So if I put it at this indent, everything else inside is part of this. So the next thing is should be at the same indent line. Otherwise, it will not understand where it is, in which block it is. So it will throw error. So make sure the indentation is proper.
Even in line 2, and that's it, yeah.
Mhm.
The slash, what does that signify?
Oh, it is just that we are breaking the command into multiple lines. That's it. You can just
we can
put it in the same line.
just
Yeah, that's it. So it's just saying that everything else, all of this is same command. Otherwise, you get syntax error. Okay. So now you see here in kids fashion, kids watches, average discount price is 687 rupees. Okay. So in badminton, 2000 rupees. And fashion sales, 1000 rupees. So this is the average discount that we are getting across category and subcategory. So air conditioners, if you see, the average is 40,000 discount. I don't know if it's true or if it's the price. Okay. But yeah, that's the concept. So how you can do the analytics on so all of this data, right? So we have not written data to the database here, but we are just processing everything in memory, all this data frames here. Okay. Now, once you have this, you can actually also go and write this to the database, to the gold. Let's see, this is having some issues with the formatting data. So when we talk about the DAG, we will talk about how the processing happens when you look at all of these data frames, including how the Spark processing happens in a DAG. Okay. Okay, so this is done. Yeah, we are able to write to the gold. So basically, you have not written bronze or silver, but you have written to the gold. It doesn't matter. So bronze and silver, you're just doing it in memory. But gold, you have written to the database. So that's why you don't see tables, the product sales, but we had some issue with the C0 ID column, right? So we are not concerned. In silver, we have not written to the database silver tables, no tables here. But gold aggregations we have written. Okay. Let's go back. End of the day. So what we have done is the processing of data set and come up with the average discount for each category and subcategory, right? That's what we have done. So what are the other questions that we can answer? I don't know if the data is correct. Probably you can take calculations here. So what we have taken here in the discount, when we calculated discount price, actual price and discount price. So this is the, it doesn't make actually any sense here, the data, right? So discount price is 32,000. Okay, sorry, it does. I was just missing 10. So actual price is 58,000. Discount price is 32,000. Okay, so the actual discount is this price minus plus discount price. Correct. So that is what is your discount. Correct. So if you want to actually look at what is the discount for each average price, sorry, for each category, subcategory. Okay, so you have to take with column, let's say, and then say, so how do you get a discount here? So let's say I want to see discount for each product.
You have to subtract this.
Right. So you do a transformation on, so before coming here, right? So in the here, DF silver. Okay. So what transformation you would write? We are adding what? What are we adding? We are adding a new column, right? Saying discount, right? So what is the transformation to add a new column? With column, right? And then I have to give column name. So which is, let's say I'm calling it just a discount. And then how am I calculating this? So I will say column of actual price minus column of discount price. Okay. And let's just say display DF silver here instead of count. We know the count. So let's run this. Okay. Does it tally?
Yes, 32. Yeah,
Right? 32, 26, 58. Correct? So this is the discount. Now let's say what is the business case? I want to get categories or say products, whatever it is, which has maximum discount. Okay. Right. So I want to get, whatever subcategories, air conditioners. So within the air conditioners, what is the maximum discount that is giving, on which product we have the maximum discount, or let's say discount, having discount greater than 20,000 or 30,000, whatever I want to do. So these kind of transformations, these are the questions that we answer based on what we have analysis on the data. So instead of getting all of this dot create or replace temp view. So I'm just registering a temporary, okay. Let's say Amazon temp view. I have registered this. Now I can go and do MySQL, okay, and select star from this view, right? Okay, so what do we want to see? Where discount greater than, say, 20,000. Okay. See here, we are getting all air conditioners. Basically, that is the one which has maximum, more than 20,000 discounts. So if you go here and see, all of this column will be greater than 20,000. Okay. Now, another question you want to answer, see, normally I don't want to see number. Okay, 20,000 or 10,000. See, 20,000. Let's say if a product is costing me 500,000, okay, or 1 lakh or 5 lakhs. So 20,000 might be less for discount, right? Sometimes. So what we do normally, we do percentage. So I want to get, say, 30% discount, or products having 50% discount, or products having more than 50% discount. That's what I'm interested in, to look at and see if I can buy something during the season sale, something like that. So those questions, right? So if a customer wants to search, normally if you open a website, and then on the left side you have filters. So let's say discount percentage is a filter. If I check greater than 50%, I have to show all the products which is greater than 50% discount. So how do I get that information to display all those products? See, in the background, you run a query something like this. So discount greater than whatever they selected, take that and run it. But it should not take this much of time, right? It should immediately display. So that's why you do a pre-calculated and store the data in the database, so that you write a where clause, quickly you will get. So if you have all the product information linked to discount percentage, pre-calculated and put it, you can just, the moment you do a checkbox on the UI, it will run this query saying, okay, where discount is greater than this, you will immediately get all the products to display. That's how the entire analytics business use cases are. I'm just giving you a simple use case. Okay. Any questions on this? I know we need some cleaning up to do. We'll publish this notebook, but you can go ahead and use the data set and run the queries. You don't need to write to database. You can just run it everything in memory for this data set. Any questions?
No, Harun.
Okay, everybody's understood the concepts?
Hi, Harun.
Yeah,
This
Subhash.
is Vashni. Just one question about this data sets itself. I'm not very clear about how to load this data sets for this notebook. Can you help me with that?
Yeah, sure. I think in the first recording we have shown how to add, but again, so it's very simple. You go here in the workspace. Sorry, go to catalog.
Okay.
Okay. In the catalog, there is something called create table. Okay.
Okay.
Click on create table, and here you will get the file path. Okay. So this is standard fixed path. Here you can give your folder name. Okay. So you can just say Subhashini.
Okay.
And then you go here and click
Okay.
whatever you want to upload the files
Okay. Yeah.
from your local. Now, let's say I just want to add some this PDF. Okay.
Okay.
That's it. It's done.
Okay. Yeah,
Now,
got
if you go to this path here, right? So if you go to notebook, any notebook, and do this dbutils.fs dot ls list. Okay. This path, this is the path where you have put, right? So you can go here. So then it will show, okay, you have put this PDF here, path.
Okay. So all the data sets which we are working right now, I can get it from the Kaggle and then load it here for my working, right? For my practice.
Yes,
Okay.
absolutely. And that's all you
Okay.
need.
Okay. Thank you. Thank you so much.
Yeah, absolutely. Okay. Now, last 10 minutes, we want to go back here, review what we have done, and see how much you guys are comfortable with these concepts. So we have done extract, transform, load. So let me know if any of these concepts we have not covered. So yeah, I know one or two which we have not, that we will do. Files, CSV we have done, JSON and so Parquet we know, right? So Parquet is what it is saving. So we know file CSV. So we'll talk about JSON and Parquet later. And then there's a session on how to parse the JSON when you are reading, how to split and write it in and get it into a structured format from the JSON format. Reading file we did. Parse columns, infer schema versus enforce schema. Anybody? What is infer schema versus enforce schema? Raju, you want to try what is infer schema versus enforce schema? No? You have Naina? This what is infer schema? We have done, right? When you are reading the file.
Data set structure.
Okay. Yeah, you're close.
Harun, can I try?
Yeah, sure. Good.
Infer schema is something like when you load a data, it automatically detects what kind of data it is and assumes like it is a string data type or something like that. And enforce schema is you define particularly like this column has to be this data type.
Absolutely. Yes. So infer schema, it will, we are asking the Spark to scan the file, and then based on the data it sees, you kind of assume or deduct what is the data type. If there are decimals, it will automatically make it a double. If it is string, it will take string. If it is numbers, it will take integer kind of a thing. Enforce schema is basically what we will enforce, that okay, each column will be this. So normally it is recommended to provide your own schema, because if there are a million rows, right, there are two issues with that. So every time you run that, it's going to scan the file twice, once to understand what is the schema, and next to actually read the data. So there is a double the effort that it needs. So to avoid that, make it faster, we give it the enforce schema. First thing. Second thing, it will help with business rules logic, right? So if some bad data is there, we can immediately catch it, in the first instance itself. Suppose there is a string coming in the double column, okay, then it will fail. Then we can say, hey, something is wrong with the source file, and send it back. Instead, if we say infer schema, and then down the lane we say evolution schema evolution is true, if they send string, it will scan it, and instead of double, it will infer it as double. And then when it start processing, it will go and convert the data type to string. So without us noticing, a lot of things get messed up. So, right? So to enforce that also, we need to it's always best practice to enforce the schema. Got it?
Yes, sir.
Okay. So read options. Basically, what are the options that we have while we are doing a read? Like one of it is infer schema, one of it is format, then file path we give, then if it is CSV, there are separate the header is true or not, is there a header, are we doing merge schema true? So all of these options, so you can look at the documentation, what are different options that are available, but the basic ones we have covered, right? Display data we have done. It's just like display, and then you put the data frame, whatever you have, and it will show the data. Display schema is again describe table. You can do. You can also do data frame dot schema. It will show all the columns we have seen. Dot columns you can see, or dot schema also you can say. It will show all the columns and the data types of the data frame. Okay. What is, you can see. So df bronze. So we can also do df bronze dot schema. Okay. And then say display. Oh, let me not do this. I'll just do schema. Yeah, the problem with it is, again, it has to scan the entire 140 files to get this. So you will get this schema here, right? So this is the schema it shows. df bronze. So these are the columns, data types, and the schema it sources the struct field, as we said, string type, name, category. So everything, discount price, string type, true is nullable or not. So all of the schema that it will show. Data frame. Anybody want to try what is data frame? Anush? We talked about this as well.
Yes, sir. Yeah. So yeah, I mean, what about data frame?
What is a data frame?
Just a in-memory collection of your your data you're trying to transfer.
Okay, right. You're close. So data frame is just a data set or your data in a structured format with schema. So data frame has two parts, data and schema. So whenever you talk about data frame, it's always a data plus schema. Data is what the entire data and schema is what are the column and the data types. Together, it's a data frame, first thing. Second, a data frame is always distributed on the cluster, which means that if you are seeing here, we will talk in detail about that. But if you see here, what is talked about? Okay, so when we looked at bronze table, right, the count, so we had 1 million rows, correct? So from all 140 things, the data frame has 1 million rows. So what it means is that 1 million rows may be distributed. All 1 million rows of data is not on the same machine or same node. So in a cluster, there are multiple machines, right? So some machine may have 10,000, some machine may have 50,000, some machine may have 100,000. If you have 5 machines, each machine will have some part of the data. Okay. How it is distributed? Again, there's a lot of algorithm and concept that Spark does, and we can also try to do partitions. So each partition is on one machine. So how many partitions we can do? So default is say 200 partitions whenever you read. So your data is divided into 200 parts by default. You can increase, decrease, whatever you want number of partitions. And out of 200, if you have say 5 machines, ideally each machine will have 20 partitions, but it's not the same always. Some partitions might be big, some partitions might be small data. So some machines will have say 10 partitions, some machines will have 20 partitions, some may have one partition, whatever it is, so distributed. But the concept is whenever you talk about a data frame, it is always distributed in on multiple nodes. If you have only one node, fine, everything will be on that node. So when you do a cluster, right now we are doing, it's a single machine node. So that's why you don't see much. Everything will be on one machine. But in production, in enterprise, when you build a cluster, you will have multiple machines. So your data will be distributed. That is what how Apache Spark process, right? Distributed computing, parallel processing. So we'll talk about all the fundamentals and how it works under the hood later. But for now, for you to understand, a data frame means it is always distributed on multiple machines in parts. Okay, think about it. The data frame does not, all data is not at one place. You should always visualize that, hey, this data frame is broken in parts on multiple machines. Now, whatever operations you do, whatever transformations you do, whatever SQLs you do, it runs on all the machines in parallel and get the results to you together. Now, the architecture also we'll talk about what is a driver, what is a node, what is a cluster, and all that we will talk about it. Clear? Any questions on what distribute a data frame, how it exists on the clusters? All right. So then we have data frame transformations versus actions. So what and lazy evaluation, these go together. So normally Spark, how it evaluates is a process is called lazy evaluation, which means whenever there is a transformation, it does not do anything. It just keeps track. It just keeps note of these are all the things that I have to do. When you do an action, that is when it will go and execute and give you the result. Okay. So simple best example here is if I say, for this example. Okay. Now, if I go just give me 5 minutes, we'll wrap up. Clear output. Okay. Now, if I run this, okay, does anything happen? Did you see the output or any jobs that are triggered or anything happened? No, right? So what it does is it just said, okay, this DF gold subcategory count is a data frame that I have to do based on whatever this is. That's it. It just put a note in the notebooks, action list to do. That's it. When you want to do it is when there is a action. Okay. Now, if there is display is an action. This group by is a transformation. So all of these are transformations. When you do a transformation, nothing happens. It just keeps note of to do things, list of things. When you do an action, it will go back and then calculate. So that is called lazy evaluation. And what are the transformations? All your, remember we did, select, group by, average, with column, right? Then rename, column rename, right? Regex, all of select, all of these are transformations, okay, which will not trigger a job. Actions are like when you are doing a read, when you are writing to database, display, so these kind of things are collect. All of these are actions, repartition, partition. So all of these are actions. So when you do this, it will trigger the jobs and stages. Narrow white transformation we will do. Shuffle also we will talk about when we do the joins. So with column we did, filter we did, group by, aggregations, joins we covered, write to table, temporary global view. So it's basically views, temporary view that we did. Global view is just has more scope. If you execute from one notebook, if you are executing another notebook from the same, the child notebook can also access the view that was created in the parent notebook. So it's just a scope. So not to stress too much about it, but we know how we can register the data frame as a view and use it as a table in the SQL within the notebook. So we have done table, write modes. We have done only overwrite. So you can also try the other modes. Append mode is there. Merge, I think, is there. So we can try that. File storage location, we looked at it, where the data, when you write to table, where it is stored, how it is stored, and all of that. Read from table and display is done. Okay. Are you guys are clear with these concepts, except with this shuffle thing that we will do later? Okay. Only shuffle and transformations, narrow white transform. This concept we will talk about later. Everything else is covered, right? Come on, guys. Tell me, are you guys good?
Yeah, it's everything good.
Yeah.
Yes, yes, sir.
Okay. So we wrap up the batch processing. So today, end of the day, I will provide all the notebooks for you guys. You can import and execute using the data sets. You have to change the path, where your files are located. And I will also collaborate with Shiva to add and give you a assignment to the same using a new data set. So you guys can all write your notebooks and submit. Just publish and put that link in the same this document, each of you. So I will look at it offline. That will help you get more confidence. You'll have a week to do that. Okay. And Hitesh and Manidhi, we will also plan some session to
Yeah.
because are not available in the earlier classes, recap classes. Okay.
Okay.
backup classes. All right. Anything else? Any questions? No? All right, guys. Have a good day. Rest of the weekend. Yeah, we'll talk offline on the group. Okay.
Okay.
Take care. Yeah, have a nice weekend. If you have any questions, reach out to me in the WhatsApp group. We'll definitely respond. Talk. Okay.
Okay.
Thank you. Yeah, have a good day.
Thank
Good
you.
Thank you.